Hello, I'm giving a presentation internally, so I figured I might as well give it externally because there's no confidential information. So here we go. Today we're going to talk about precompile for training, and to do that we're going to go through a simple example. Imagine that you have a very simple model that looks like this, where you take in some tensor, you do a mapmul with itself, and the call sign. So under the hood, torch.compile will capture the graph, and then it will generate two things. It will generate the kernels. So on the right side, you can see this Triton TEM fuse MM sign. And this is not all the code, but you can see some of the code. And basically what torch.compile has done is it's detected that you can fuse the sign into mapmul and gone ahead and written a single kernel with both. And then secondarily, torch.compile will generate what's called glue code, where it's basically the code that calls all the kernels in succession in the order that's important. And what is precompile? Precompile is this technology that we use to basically serialize this glue code, this kernels, and really any other important thing that you need to run your code onto disk, onto a file on disk. So that's the challenge with precompile. So maybe we can walk through a little bit of the code on how this happens. So one thing you'll notice is that in all inductor output code, when we stamp out the kernels, you have the kernels, you have this Triton.jit, which you're probably familiar with, but there's also this Triton.heuristic decorator. And this is the magical decorator that we hook into to serialize kernels. So in particular, if you look at the definition in inductor runtime Triton heuristics template, you can see we return this cache autotune object. And in this caching autotuner, you see we do this interesting thing in the constructor where we basically will set the environmental variable Triton cache dir to the Triton cache dir that we know about. And so what this allows us to do is when we actually compile kernels and we get back their hash, we know exactly where Triton has put that kernel on disk, and we can basically record the hash, we can record the cache directory, and this will become useful as we'll see. So basically we have this, where as PT2 is calling Triton to do compilation, Triton is returning hashes corresponding to the kernels it generated, and those correspond to files on the file system. And so what we have to do serialization is what's called a Triton bundler. And what this effectively does is it iterates through all of the kernels we discovered as part of compilation. And then we read the file in, and then we can kind of bundle it into a single serializable object. And so the mental model here is basically this bundler is reading these kernels and then bundling it into a precompiled artifact. And then lastly, there's the deserialization path. So on the deserialization path, you see this AOT compiled function.deserialize, and then that will eventually call this Triton bundler read and emit. And what this is effectively doing is the opposite. It's effectively going from the precompiled artifact and then putting the kernels back on the file system with the exact hashes that we expect, such that when we run the code, the kernels are there, and things just kind of work as if you torch compiled on a single node and ran it there. So this is just kind of a look into kind of the basics of the glue code and kernel serialization. There's a lot more that goes on under the hood for precompile that we won't get into today, but hopefully this gives you a good taste of how things work under the hood. And then lastly, we talked about precompile a lot. Let's talk about what it means for training. Well, what's nice is once we have precompile, it means that we can basically do compile once, run everywhere, right? Where we do a precompile on a single GPU, we get this precompiled artifact, we can rsync or whichever mechanism we want, move it to all these other GPUs and invoke it. And then I guess the last thing I'll mention is that what's cool about the PT2 stack and precompile is we can actually do what's called cross compilation, where when we're doing this initial compile, we actually don't even need a GPU. We can do it on a CPU. We can compile this artifact, and then we can move it over. And so yeah, that's at a high level precompile for training. Hopefully this was interesting.